everyone, it's Austin here coming to you live with a chemistry video. Video 1 on Raoult's law. So what does Raoult's law say? These will be short, y'all, so here we go. Raoult's law says when you add a non-volatile solute to a solvent, it will cause the vapor pressure of the solution to decrease. And this is of an ideal solution. Non-volatile basically means that the solute's vapor pressure is 0, so when vapor pressure is 0, that means it will not evaporate. It will not vaporize. Okay, so we have a problem here. Let me also say that this is the equation. It says that the pressure of the solution equals the mole fraction of the solvent times the vapor pressure of the solvent. So let's work through one of these. And this picture here, before we work through it, basically shows you and me if we have a pure solvent, it will have a high vapor pressure because all these molecules can be, they can be vaporized. But when you have a solute added to the solvent, that solute, which is in red here, mixes in with the solvent, and it doesn't allow as many of the solvent particles to evaporate. Remember, the solute has 0 vapor pressure because it is a non-volatile solute. So the only thing that can evaporate is the solvent, and it will not evaporate as much because there's solute in it, and it's kind of blocking it from evaporating as much. So the vapor pressure is decreased here. So let's work a problem out. Okay, so I'm not as good as these other guys on YouTube, obviously. I'm pretty unorganized, but it's going to be good. So calculate the expected vapor pressure at 25 degrees Celsius for a solution made by dissolving 158 grams of sucrose in 643.5 cubic centimeters of water. At 25 degrees Celsius, the density of water is 0.9971 and the vapor pressure is 23.76. So, the first step, let me move this up here, and we got some equations. We have way too many equations here. Alright, here we go. So here's our main equation. So the first thing we need to find out is mole fraction of the solvent. That is moles of solvent divided by moles of solvent plus moles of solute. Okay, so the question will help us to find these. Stay with me, y'all. Here we go. So the moles of the solvent, what's the solvent? Well, it says the solution is dissolved in water. Sucrose is dissolved in water, so water is a solvent. So we have to find mole fraction. We have to find moles of solvent, moles of solute. Solute is here. It gives us the grams in the question. 158 grams. You have to convert it to moles, so you have to look up the molar mass of sucrose, which I did. It was given to you in the book, I think. And you convert it to moles. So that's how many moles of sucrose. Now, moles of water, they didn't tell you the grams of water. They just gave you a density, and they gave you a volume. So you use this equation, volume times the density equals grams. So now you have grams of water. So now you convert from grams of water, 641, times the molar mass of water, 1 mole per 18.02 grams, gives you 35.6 moles of water. So what we have now is moles of water and moles of sucrose, and now we can solve our mole fraction. So, come over here, mole fraction, we put our moles of the sucrose and moles of water. So it's the moles of the solvent right here divided by moles of solvent plus moles of solute, which you found there. You add them up, you divide, and there's our mole fraction, 0.9872. You can work that out. 0.9872 is the mole fraction. Now what else do we need to know? We know this now. What's the pressure of the solvent? Well, it tells us it's 23.76. The vapor pressure of the water, which is the solvent, which is what's dissolved in it, is 23.76. So what we have to do now almost done with this one. 0.9872, which was our, hold on, it was our mole fraction times our vapor pressure of the solvent, which was given to us right here. Mole fraction times vapor pressure in torrs gives us 23.46. So what happened? The vapor pressure of the water, which is a solvent, was lowered from 23.76 is what they gave us in the problem to 23.46. So once you added that sucrose to that water, the vapor pressure came down. That solution's vapor pressure decreased from 23.76, which was pure water. Then you added the sucrose, vapor pressure decreased to 23.46 torrs. So there you go. Raoult's law number 2, check it out. We'll be doing a little different kind of problem. Hopefully it'll be good and helpful. Peace out, guys.